I'm Kristin Day. I'm a data scientist at Allegiant PLC, but I'm also starting something on my own, working in healthcare with AI. And so today I'm going to be talking to you about using Python for artificial intelligence. So a little bit more about me, but I'll keep this brief because I know that's not what you're here to hear about. I teach Python and data science online. I work with Python and I have fun with Python. And if you want to know more about my education or my background, feel free to ask me at the end. So, like I said before, we'll be discussing using Python for AI development. But first, what is AI? Have any of you guys worked in AI or data science or machine learning? A few of you? All right, cool. Does anybody have a definition for AI? It's all over the place, right? Some people think if you use machine learning, it's AI. Yeah. Huh? Skynet, yeah. Yeah, so let's define it for our purposes. My favorite definition of AI is artificial intelligence is the science and engineering of making computers behave in ways that we always thought required human intelligence. And so it's getting a computer to do something in a way that a human would do it, essentially. So there are a couple kinds of AI. When you're talking about AI, there's what we call narrow intelligence and general intelligence. In the current state of AI, and probably anything that any of us will see in our lifetimes, is narrow intelligence. And that means the models and the systems that we're building, they can only handle the information they were built to handle or the data that they were trained on. And so they can't understand anything that we haven't taught them. They can't generalize that information to other things they haven't seen yet. So this is unlike human intelligence, where humans can generalize information. If you want an example of this, you can think cats and dogs. So one of the really common computer vision problems that people try and solve are distinguishing, animals, so specifically cats and dogs. You showed a picture of a cat, it can say that's a cat. You showed a picture of a dog, it can say that's a dog. And it does it really pretty well. But you show it a picture of a bunny, and it's not going to have any idea if the bunny is a plant or a human or a car. It's never seen it before. So anything you don't train a computer to understand, it's not going to understand it. It's not going to be able to use the things that you taught it to understand new things. Instead, if it sees a bunny, it's going to try and give you the probability that it's a cat or a dog. So should we fear that AI will take over the world? Well, the short answer is no. Like I said, the current state of AI is lifetimes away, if ever, to getting to generalized intelligence. And this means computers can do only what we train them to do, essentially. But the long answer is there are still ethical concerns with AI. If we feed AI systems biased data, we will get biased results. And this can have real-life consequences for people. Some examples are mortgage industry. So mortgage lending, they might take data out that indicates, whether you're from a poor family or a certain race, but you can still get some of that in your data by figuring out what neighborhood a person's from. And so you might have great credit and always pay your bills, but if you live in the wrong neighborhood, it might treat you a little differently. So these kinds of biases can have real-world implications on people, and it's something that we have to be aware of when we're building artificial intelligence systems. Okay, so why is Python great for artificial intelligence? Well, there are all kinds of reasons, right? And you guys know what they are. You wouldn't be sitting here, I'm sure. So one of them is it has a great library ecosystem. So if you think of all of the resources that are available in Python for artificial intelligence, you span the gamut from NumPy, SciPy, scikit-learn, Keras, TensorFlow, CAF, you name them. It's a huge library that you can use for artificial intelligence and machine learning. Python is an easier language to learn than many of the other languages, so there's a low entry barrier to learn it and get into it. It has a lot of flexibility, so you can code in notebooks, you can script things, you can use it as an object-oriented programming language. You can use it in a lot of different ways. It's platform independent, so you can use it on a Mac, a Linux, a Windows machine, and 21 other kinds of operating systems. 21, yeah. The readability of it, it looks more like natural language than other coding languages. So similar to it being easy to learn, it's also easy to read and understand compared to other coding languages. There are some great visualization options with Matplotlib, Bokeh, and various other packages for data visualization. I get in an argument with my coworker all the time that Python's better for visualization. He says it's R. I'm not going to go there. So and the other great thing about Python is it has really great community support. Because it's open source, it's great that a lot of people are still really involved with it, and it has growing popularity. So there's still a lot of contributions that are coming in. Okay, so what's the biggest barrier to AI? Does anybody have any ideas? Like what makes it hard? Exactly. Data is one of the biggest barriers to AI. Getting the right data and getting clean data and getting usable data that works is really difficult. And I like to think of my data, I hear a lot of people compare getting data to like an oil mine, and it's really valuable, and that's true. But the thing is, when you're getting crude oil, it takes a lot of things you have to do to it before you can use it. And I also like to think of getting data more like a marble quarry. So if you mine your data like in gravel, it's really not going to be as valuable as if you mine your data like a large slab of marble that you can use for a countertop. So you really have to think about how you're getting your data, how you're creating your data, how you're saving your data, so that you can use it in a way that's more valuable. So to that end, we want to start thinking about data as an asset. And how do we value data as an asset? Anybody have any ideas? Like what would give data value? Yeah, it could be. What I'm actually thinking about here is a lot of people, when I ask at work, why is data valuable? And the first thing they think about is how our company can use it. Why is it valuable to us? What can we do with it? And of course, that is definitely something that you want to think about, but a lot of companies are also thinking about using their data on their asset sheets. And when you think about using data on an asset sheet, you have to think about how you're going to value it. And you could think of it both in terms of what you can do with it, but also how hard is it to get that data labeled. A lot of times, really valuable data needs a label. So if you're thinking about specifically in healthcare, a lot of healthcare data would require doctors to label it. And so when you're thinking about how much would it cost for, say, a radiologist to sit down and label, I don't know, 10,000 images of like x-rays or CAT scans or whatever, well, that's really expensive, right? And so if you can get labeled data like that, that's a really big asset because nobody else can get it, or there's a high barrier to getting it because it costs so much to get it labeled. Okay. So relatedly, how do we value AI systems? So you're trying to convince your company, hey, we should build this AI system. It's going to be really valuable to our company. Any ideas how we might convince our company that our AI system has value for them? Yeah, absolutely. Yeah, definitely make them money. But that's not the easiest argument, right? Okay, so there are three ways that companies usually distinguish themselves in markets. One is by quality. They usually say they have the highest quality product. The other one is cost. They say they have the lowest cost product. And the third one might be they're in a niche market. And so when you're thinking of the first two especially, you can really show value in AI systems because you can use AI to create more valuable products. And you can also use AI to provide a lower cost for your product because you can create efficiencies for the workforce and for workflows. So the future of AI as we know it I believe lies in human-in-the-loop artificial intelligence systems. And this is really becoming the cutting edge of AI technology across the field. And essentially what it does when we're talking about data and getting valuable labeled data is it uses humans just in their natural kind of work setting to, as they are doing things, it watches what they're doing and saves labeled data that can be used on the back end. So here's one of my favorite examples. And I wish I had the one from Amazon. I tried to pull a screenshot of the Amazon chatbot for you guys because I absolutely love it. It's really hard to find. You have to dig for it. But when I found it today, it wasn't working. So this is what you get instead. So when you think about a traditional chatbot, you think there's a lot of free-form text entry, right? And when you're getting free-form text coming in, that's a really hard thing to process because somebody could type anything in. They could have misspelled words, they can have bad grammar, they can have slang. It's really hard to process that and work with it. So instead, the chatbots that I really like to see are the ones that actually predict responses because then a person has the option to click the right response. If the right response isn't there, a lot of them will also give you an option at the bottom to type in something. So the more responses you collect, the better the predictions get. And you're collecting clean responses that can be turned around and used for better predictions. And then you take the text that's coming out for the ones that aren't there, and you continue to train your models on the text that's coming in so you can maybe predict some labels that you didn't have in the beginning. And the longer these kinds of systems run, the better they get. And so this is just using a normal human action. They're going to go and use the chatbot anyway. You're not taking them out of their way or causing them any pain. A lot of times you're actually making it easier for them because they can just click a button. They don't have to type in words. And I know for me, sometimes when I'm using a chatbot, I'm not even sure what to say. It's like, what am I trying to talk to the customer service guy about? Well, my package didn't show up on my door. And I'm like, how do I write that so a computer will understand it, right? And that's kind of hard for me. So I actually prefer it when I have labels that are predicted, especially if the right one comes up. Okay, so what is required for these systems? Well, there's a lot that goes into them. Because you're designing a system for a human to use, you have to have UX and UI support. Because you don't want humans, if it's too hard for a human to use, they're not going to use it. Or they're going to find a way around it, or they're going to shy away from it in some way. So you have to have UI, UX, a little bit of user research in a lot of these systems to make sure that they're easy for people to use. The second thing you have to have is data science and machine learning. I'll also throw in here, we have a data integration / data warehousing team. And they're great at organizing and storing the data in really usable formats, making sure that our data systems have fast access and are easy for us to hook into. Then you've got your data science, machine learning people who are going to actually build the predictive models. And you also have to have your software engineering team to actually build the system for people to use. So there's quite a few pieces that go on in these human-in-the-loop systems, and it requires the cooperation of several departments working together. Okay. So this is just kind of another illustration of how this workflow goes. So you've got the human here using a computer with a software program on it. It's been designed by the UX and the software engineering team. As the person uses the system, you've got the data coming out on the back end and going into data storage, where the data is cleaned and organized and stored in a usable format. Your data science team and machine learning are using data to create prediction models. The prediction models feed the data back into the software platform, and the cycle goes round and round. So the more predictions you have, the better the system gets. You're collecting nice, clean data that's really easy to use, and you've got a few spin-offs. Now, will this system work in every AI system? No, it won't. A good example, Alexa. the speech to text, there's just not a natural way to have somebody transcribe text as part of their job. So it doesn't work for everything. Actually, I happen to know that Amazon hires people to sit in a room and listen to what you ask Alexa to do, and that's how they get more data and feed it back in. And sometimes that's just what you have to do. But a lot of systems will work this way. In fact, I know specifically if you're thinking about like radiologists as an example, well, they're sitting there clicking on images, looking through them, and writing up reports that go with the images. So it's really pretty easy if you create a text prediction algorithm. As they create their reports, it can predict the text of the report, so you get the same language every time in every report. And with uniform language, it's easy to match up the right labels with the right images and get labeled data, which would be really, really expensive to get any other way, because again, you're paying a doctor who makes, $500 an hour to sit there and label your data for you. But if you create it into a platform that they're already using, it's not them going out of their way, and you can also make their job easier because they don't like to type out reports. So I would really encourage you, and the point of all this is really for you to think about when you're designing systems that people are going to use in Python, think about what's going to happen to the data, how you can use it, how you can create the system in a way that it's easy to use, but also gives you nice, clean labeled data that you can use on the back end. That will create a lot of value for you and your company in just about everything that you do. So, sorry I don't have a really nice ending slide here, but thank you for listening to me. I hope this has been helpful, and I also hope that you have lots of questions. So.
Yes, if you have questions for Kristin, I'll give you guys the microphone. All right. 3 for 3.
They're good. It's a good night. You mentioned the data thought of in terms of assets. Can you also think of them in terms of metrics?
What do you mean by that?
So when you mentioned that data in terms of assets, you gave the example of like labeling, right? Like having somebody there and I guess quantifying how much it would cost, you said, if they were labeling there versus, I'm assuming, automating that through AI. Did I get that right, or I didn't quite understand?
Sure.
What
Yeah,
you
I can
meant
explain that a little better. Yeah, no problem. So okay, the radiology example is the best one that I can think of, right? And I know I used it already. But if you don't have a system that's watching a radiologist as they are reading images and writing up reports for them, right? Or if you have a system where, okay, let's say you could even get a hold of the data, which you can't because the hospitals have it, so that's really tricky, right? But let's say you could get the data that hospitals currently have without one of these systems, right? The reports that go along with the images are really messy. They're not uniform, right? So they're all different, and so you get into a real natural language processing kind of an issue if you try and pull keywords out and attach them to images in that way. Now, if you have a platform that's predicting uniform text and says, how about this paragraph? They say, yes, inserts it. How about this paragraph? No. How about this one? Yep, that's it, inserts it. Well, you have the uniform text. It makes it easier to get out the right keywords to match with the images. And so doing that, you can pull the data out kind of naturally, just as a radiologist goes about his normal workday, right? So you don't have to pay him to just sit and label data for you. You can just collect the data that he's, just already kind of developed as he's doing his work. Does that make sense? So when you're thinking about how valuable that data is, well, nobody can get their hands on it, right? So if you, let's say, worst case scenario, your company tanks, but you have this data asset that everybody wants to use and nobody has, right? So that's when you're thinking about how valuable your data is. It's like, man, in bankruptcy, somebody would buy that, assuming they can legally do it with HIPAA and it's anonymized and all that. Okay, there's a lot of things going on in healthcare data. But that's what I'm talking about.
So if you're thinking of your data as an asset, what point does it actually become a liability in that same situation that you're speaking of?
A liability meaning?
Meaning that everything on Earth is hackable, and now you have all of that data that was supposedly anonymized, but I know it wasn't for a fact because you have another database with all the same user IDs that I can match up. So therefore, I've just made you liable for $1 billion worth of damages.
So I'm not a cybersecurity expert. Let's put that out there. I do believe for artificial intelligence purposes, you can anonymize the data because you don't have to keep it, you don't have to keep an ID on it. Yeah, so I think you can anonymize. It's my understanding from the people that I've talked to that it can be anonymized because you don't ever have to link it to another system, so you don't need to keep an ID on it. You're just using it for training purposes to link keywords to what you're saving is just an image and keywords. And you don't have to have any kind of ID to link it to another database anymore. So I think you can actually anonymize, at least in that situation. Outside of that, I'm the wrong person to ask. I'm not a cybersecurity expert. And most of the data I work with, so my day job is in Allegiant PLC. We're a door hardware company, so we don't have a lot of problems with that. But come to one when somebody is talking about data security. Yeah, you should ask for one, yeah.
What is it? I know we're talking about Python here, but is that the leading language for artificial intelligence development, or that'd be like C++ is something more used since it's more like towards the bare bones?
Yeah, to the best of my knowledge, Python's the best language for machine learning. I know people who use R. I know you can do it in JavaScript. I mean,
So it's
Google and Facebook both use Python. Facebook, I believe, developed PyTorch. Am I getting that right? I think that's right.
Okay, so they're
I know
using
Google's TensorFlow, CAF. So all the big companies use Python for machine learning.
Okay, so it's gotcha. More
Yeah.
high level kind of programming languages with low.
Now, R does have a pretty big following as well, and I do know some people who use R. To the best of my knowledge, Python's the most popular, but
Yeah, it's the only one I've really seen. But
yeah.
doesn't-
Yeah, R has Carrot, so it does have some packages, but everybody I know uses Python for machine learning.
We can't find those R people because they're not around here, right?
We're in the wrong meetup.
Yeah, definitely. Any other questions for Kristin? Oh, hold on, wait. There's people on the stream who care.
So, like, just going to your healthcare side gig, with a lot of like insurance data and hospital data, you're just studying something that's observed, like people who actually bother to go to the hospital, people who kind of already know something is wrong or sick, right? So, what are some ideas, maybe not solutions, to combating the fact that you're only studying things that are observed and recorded?
So you're not always. In fact, there's a really famous example of this, and I can't remember who did it, but it was some research guys, I believe in Northern California, like a professor and a student, and the student had a project, and he was really interested in trying to find out about drug interactions. So if people taking multiple drugs, because you can't really do a study on every possible drug combination, and some people really take a lot of 5, 6, 7 different medications. So considering all the possible combinations of all the different medications, it's just really hard to understand that. So the student tried to get data from Google, like search data from Google, and couldn't get it, and talked to, which is actually, that's a really important note when we're talking about data value, because if you notice, Google releases its algorithms, right? It releases TensorFlow, it releases a lot of the algorithms that it uses. So it's not the code that's important, it's the data. And Google really holds on to theirs. So what the student actually was able to do, Microsoft is a really great partner for a lot of projects, and we actually partnered with them for their computer vision software that you demoed, and they actually do have a custom model. But yeah, they're really, you gotta, their documentation's terrible. So anyway, but Microsoft partnered with him and gave him the data, and he's like, man, I really wish I had Google data. Well, it turns out you can get Google data from Microsoft if somebody used Internet Explorer to search Google. So he got all this data from these searches on Bing and Google from Internet Explorer, and actually found a lot of information about some really dangerous drug combinations from people's search history. So there are ways, and I actually participated in a conference a few years ago where a lot of data scientists are trying to use social media data to find all kinds of different solutions to things in the legal world, to things in the medical world, and so there is a lot of work around those kinds of things.
Very cool. Question here?
I really like the ninja move of getting the doctor to fill out the form for you without having to pay him explicitly to do it on his free time.
Yeah.
Or her free time. My question for you is, how does second opinions factor in? Because, I mean, not to belittle any doctor's experience, but it's definitely a factor.
Absolutely. Yeah, that's a good question. So I was actually talking about this in regard to self-driving cars the other day. So I don't know if you guys are familiar with reinforcement learning at all, but okay, so maybe I'll get to it. So this is a little bit long. I have long explanations, I'm sorry. Okay, so reinforcement learning is kind of like when you play Pong, and if you lose, the computer loses a point. If you win, the computer gains a point. And so as you play, it's like win-loss, and it learns by the scoring, right, and not by what you're doing. Well, when you're a self-driving car, you have people driving cars, and so it's learning what the people are doing. And so what they're calling that is kind of a spin-off of reinforcement learning called imitation learning. And so what I was talking to somebody the other day, I was thinking, man, you know, my first thoughts on this were, I don't really want a car to learn to drive like me, right? Because I'm a terrible driver. And so, like, if the car's learning to drive like me, that's maybe not the best thing in the world. But I think there's kind of a wisdom of the crowd situation. So the more people you watch, the better the car is going to do overall, because it's going to kind of average out the actions of everyone. And I guess maybe there would be a little tuning on the back end of that, right? Like, if everybody does something poorly, then we've got to find another way to teach the computer. So I think it's kind of a similar thing with the doctor data, is like the more doctors you have using the platform, the better it's going to perform. Yeah.
So I was going to ask about the technologies you seem to be talking about were a lot of machine learning pre-compiled models where you're feeding it labeled data to train the models, but reinforced learning where you can basically in real time give it a score, like, you know, a positive or a negative. How do you think that's going to affect the healthcare industry? Because then the machines are going to have to come up with a scoring mechanism or some way that they can in real time start making these judgment calls based on winning and losing. Is it relevant? Is reinforced learning?
Can you give me like an example?
I wish
of
I could. I don't know. But I'm wondering, because there's a difference between like the pre-compiled models versus like the reinforced learning.
Yeah, so the human in the loop isn't the same as a reinforcement. If anything, it's more like the imitation, because you don't want to remove the human from the loop, right? Like, that's not the point. The point of the human in the loop is really just to make the loop more efficient, to make the human's job easier. The plan isn't get rid of the human, although maybe that could happen in some scenarios. And so there's always going to be a human there checking off, like, yes, this is correct. No, this is incorrect, right? And you would be surprised how many systems you already use that involve that. As I know, Google Search still use people on the back end in some scenarios to like double check things here and there, like the chatbot scenario. Uber customer service does that as well. So they start out with a chatbot, it gets sent to a human response with a template. So a lot of things that appear to be fully automated surprisingly aren't fully automated.
So it's still kind of a lot of mechanical Turk behind the scenes pulling the strings?
The old definition of mechanical Turk, yeah. So as opposed to Amazon Mechanical Turk?
Right,
yeah.
Exactly. Yeah.
Yeah, it is. Yeah.
So I don't know if I have a question, but this kind of relates to that topic.
one way to kind of classify the spectrum of these AI or ML problems is that it could be assistive, where they're providing information to the human to then make a decision about things. So an example would be the recommender when you're on Amazon and it says, oh, people who bought this or looked at this also looked at these items. And so then you still have to make a choice about what you're going to do.
Right.
So that's part of the human in the loop thing.
Exactly.
And it kind of goes all the way from that to more of an agentive form where it's actually doing the process. It's imitating you. It's doing the driving. It's doing that sort of thing. And so, like a simple example would be the Spotify weekly discover. Like you still have to click play it, but you click play and it goes all the way through that playlist that it generated for you. So
Right.
So I think it's hard to wrap our minds around that because we see the word AI, and it's like it's all of that. It's that whole spectrum of things.
Right. Yeah, totally. Yeah, thank you. That's a good clarification.
When or have you experienced a time when you encountered a problem where you had a data set that was just so big or an algorithm that wasn't fast enough to where a problem was out of the time scope that you had? Like, are we to a point where there's too much data to filter, or a model is so complex we can't train it in time? Like, have you encountered a time box on any of your problems?
Yeah, so I guess for me, training can take a long time depending on what you're doing. In terms of a data set being too big, you can sample from it. So when it really gets to be a problem is, let's say you're trying to classify 500 different types of images, and let's say the ideal sample size for each image is 10,000. So that's that's like a ton of images, right? Whereas if you only want to classify, you have 1 million images, and they're all cats and dogs, and it's a balanced data set. Let's say it's like an ideal world, right? And so like if you're only trying to classify cats and dogs, you can just do a stratified sampling, which means equal sampling from each type of thing that you're trying to identify. So you don't have to run everything that you have through it, right? And some of those bigger problems, when you have a lot of different things you're trying to classify, sometimes it's better to split those into separate models and do like an ensemble kind of thing. So there are different ways to handle that. They've got GPU processing, but yeah, sometimes training can take a really, really long time, depending on what you're trying to do. But I've never been in a situation where that caused me to not do the project. So.
When you have a human in the loop, how do you avoid cognitive bias if it's like a recommender?
That's a great question.
Yeah, because I was thinking about that with, like in my case, or not my case, but my experience, my mom had some drug interactions that led the doctor to think that she was having Parkinson's, even though it was the drug interactions, but she gave all the symptoms. So from a recommendation, whether it's the human or the AI would both say, well, this looks like a 90% chance that it's this condition.
Right, yeah. I don't know if I have an answer for that. I guess my best answer is, like, whenever you're creating these systems, like, try to think very deeply. I guess, so my, Evelyn, she was the right brain speaker. That's your name? Okay, good. Like you were saying, it was winding path, right? So my path here started out with me as an attorney. So I tend to think through my data problems like an attorney, like, what are all the other things that could cause this, right? Like, what are all the different things that could explain this? And then I try to really, you just have to think very carefully about the decisions that you're making, which features you're going to use, what impact that could have. But it's not something that's really solved.
Awesome. Any other questions for Kristin? Oh, hold on.
Yeah, but he's been asking questions.
You're cut off after this one. Okay, no, I'm just kidding. Just kidding. Yeah.
Oh, I was just curious how Internet Explorer was able to find those Google results, where I guess other browsers weren't.
Microsoft saves everything that you do on Internet Explorer, so I don't know if that creeps you out or not, but So Internet can see what, or Internet Explorer can save everything that you type while you're on the browser. Yeah, they save everything. Well, they only save it for, I want to say, like a year and a half. But only a year and a half. I can't remember exactly the time frame. It's not forever, but they do save it for a while. Yes, please stop using Internet Explorer. Yeah.
Do you have any final thoughts on like the final outcome of the AI singularity issue that all the luminaries are talking about? Like
AI singularity.
the Elon Musk, like when the self-awareness business and the fate of humanity and all that kind of stuff.
I'm not. I don't know.
Skynet, basically, yeah. General AI.
They are pledging to not make Skynet happen. Is
Yeah.
basically what Elon Musk and crew have
But what
said.
we've actually learned is the computers are really dumb. So it doesn't matter.
This is true.
We're centuries away, and or one really smart guy away.
Yeah, well, so, that was kind of the point of this slide about should we be afraid of like AI taking over the world? Well, no, because computers are really dumb. So they only know exactly what you show them. And I guess, my little deeper thought on that is somebody was telling me, computers learn differently than humans. And I'm like, well, sort of, right? Like we don't really know what's going on in our brains. So, we're probably not turning things into numbers in our head before we figure out what's going on. But similarly, when you think about data science and you think about how you learned everything that you learned in your life, if you think about a human and how our bodies work, we have all these sensors everywhere, right? Like every nerving ending, we have our eyes, we have our ears, we have our nose, we have our mouth, like all these senses and all these nerve endings. And so we're constantly getting data into our brains, like all the time. And we're also constantly surrounded by people who tell us who things are and what things are. And like from the time we're a kid, that's a cat, that's a dog, that's a bunny, right? And so like if you think about how a computer learns, it really learns the same way. It has all these inputs and we're telling it what these inputs are. It just doesn't have as many of them coming in as often, right? So I guess if a computer ever got to a point where it had as many data points coming in as we do and as much support kind of around it, telling it what all that stuff is, maybe it could be smarter. I don't know. But the current state of things is a really long way from that. So I think we're safe. Huh? Nah, not at our company. Yeah. For like Google, probably. If for us, we think about custom models, and we do have one project at my job where we're doing a custom computer vision model. But usually it doesn't really make a lot of business sense for us because when you think about the difference between how TensorFlow is going to perform and the difference of a custom-made model. Like in academia, I think when they're building custom models, they're like, can we boost the accuracy by 1% or 2%, right? And in a business context, most of the time, it doesn't make sense to spend the time or money to do that. So I think for us, getting clean label data is more important than trying to boost the accuracy of our model by 1% or 2%. And we seem to have more more bang for our buck working with the data than the model.
Do you mind repeating the question?
Huh?
Do you mind repeating the question for the recording?
Oh, sorry. Yeah, he asked if there were a lot of, I believe you said mathematicians on the back end of AI systems that were hired to do or create AI systems. Is that? Yeah, did I hear that right? Yeah. And then the second one was. Yeah.
Who's leading the charge?
Who's leading the charge? Yeah, so I actually got my AI for business certificate from MIT, and they were fantastic, but I believe they are considered really the second in AI, and Stanford is, number one in AI right now, yeah.
It's kind of old school East Coast versus West Coast.